Let's say I have a matrix 3 by 3 and it's A equals 1, 2, 3, 4, 5, 9, 0, 0, 1. Yeah. And I want to do the inverse of this 3 by 3 matrix. Just for the sake, can I just put here minus here? Yeah, minus 4. How I'm going to do the inverse? Question is find or calculate A inverse. A inverse has a formula. This is my master equation. Yeah, A inverse is 1 over A determinant and then joint of A. Okay, first thing, this is my formula. First thing I will do is I will find the A determinant. Okay, let's call this one our master equation. So we will come back to that equation again. First, we need to find out the A determinant. So let's go to the next page and we find the A determinant. So I like you to try finding the determinant of this matrix. So just pause it and try to find the determinant of this matrix. Want to do. Now, if you got this type of matrix, obviously I've shown you how to find the determinant the long way, but I show you easy way as well. You see that one? I will make sure the Super Mario comes here. So that's where I just park my Super Mario. You know, the Super Mario is here and here. So I'm looking at this one. Yeah, this is 0, this is minus 0, this is 1. So I can do that one, and I can do 1 minus 4, 2, 5. Yeah, 5 times 1 is 5. That times this is minus 8. Determinant is minus 13. Same determinant as I got you. The reason is because there were 2 zeros, so I could have parked the Super Mario straight over there, and then I can do that. You can do the long method, which is 1 plus 4, 0. It will still give you the same answer. Doesn't matter wherever your Super Mario is, you will get the same answer. So this is a quick one of find the determinant. Okay, determinant done. Why put plus? It's a plus 13, not a minus 13. So I can go back in my master equation and put the value of A determinant as 13. Okay. Now your second step, step 2. Step 2, you have to find in the master equation that thing was missing, adjoint or adjugate of A. How do we find that one? Because it's a 3 by 3 matrix. Now, the matrix I got was, let me just go back. The matrix I got was, can I have the value for the matrix, please? Is it right? Yeah. Okay. So I got the matrix. Now, after I got that one, I need to find this adjoint of A or adjugate of A. But it's a very long process. The second step is I need to find out the minors. Rather minors, yeah, minors. Minors of each element. How do we find the minor for each element? We make sure our Super Mario is at each element. So Super Mario is here and here and here and here and here and here. And then we create a matrix of minor. So let's do the matrix of minor first. So what you do is first I need to find the minor of 1. When I find the minor of 1, this is what I will do. I will hide that one and that one. Yeah, I'm not going to write 1. This is the minor, that's the thing. But when I do the matrix, if I say, can you pick where is one? You will ask me which one we're talking about. Are you talking about the top one here? Or are you talking about the bottom one here? Which one? So these are way we actually name them. We call because the matrix is A, so minor. The mini-me's or mini-A's is A11, the first row, first column. A12, 13, A21, A22, A23, A31, third row, first column, A32, A33. Yeah. So I need to find the minor for elements A11. How I do that one? I write A11 here, yeah, and then put the determinant sign 5901. 5901. And just the way you solve it. 1 times 5 is 5 minus 0. So A11 is in fact 5. Yeah. So what I do, then I rub this thing here and I put 5 there. Yeah. Now I need to do that one with all the elements, So if you can try with A12 as well. You do this for A12, obviously you are here, so Super Mario is here and here, so you got 2301. So the answer is going to be, if I solve it, that times that is 2 minus 0, which is just a 2. So you rub this bit and put a 2 there. And you do this one for the A13, so here and here, 2539. So 2539. 9 times 2 is 18, minus 5 times 3 15. That's a positive 3. Now let's say I want to find out for A21. A21, which is here. So you see that Super Mario is here. So Super Mario can go that way and that way. So 4901. I mean minus 4. Minus 4901. 1 times 4 is minus 4. 9 times 0 is 0. So the answer is minus 4. Yep. When we do the A22, which is this, so Super Mario is here and Super Mario is here. So 1, 0, 3, 1 is left. 1, 0, 3, 1 is left. 1 times 1 is 1, minus 0. The answer is just a 1. So I rub that one and I put 1 there. I want to find the A23, which is here. A23. So that one, Super Mario is here. Can't see that one. I can't see that one. So 1 minus 4, 3, 9. 9 times 1 is 9. Minus 4 times 3 is minus 12. So minus minus 12. That becomes a positive 12. 9 plus 12. That is 21. So I can rub that one and I can put here 21. If I find for this element A31, so is that and that. Here I left with these ones, minus 4, 5, 0, 0. As one whole row is 0, I don't have to calculate. The answer is 0. B2, which is here, so that and that. So 1, 2, 0, 0. And that value is automatically going to be 0. So I can rub this bit and put straight away 0 here as well. Now we got this element, so that and that's gone. So we left with these 4 elements, 1, 2, minus 4, 5. So that times this is 5, minus that times this is minus 8. So minus minus 8, 2 minuses makes a plus. The answer is 13. Now we got the matrix of minor. This matrix, after performing a massive large operation, is known as AM. AM, where M is a matrix for minor. It's known as minor matrix. Now we got the A minor matrix. Now we use a technique called diamond. I call it diamond, people call it something else. Diamond means for every alternate element change the sign, but rather doing every alternate element, I just draw this diamond. So where this diamond is touching, change the sign. So whatever sign is here, make it negative. Whatever sign is here, change it positive. That doesn't matter. This sign, make it negative. Yeah, you change the sign. The sign of these ones, the negative negatives, what actually happen is these becomes a matrix of cofactor. So now this thing we write is matrix of cofactor. So now this thing becomes a matrix of cofactor, AC. That's the name, AC. So matrix of cofactor. Once you got the matrix of cofactor, after you change the sign, we do. So when you have the matrix of cofactor, after you change the sign, this is minus, that becomes a positive, that becomes a minus, and that becomes minus as well. Yeah. What you do is you transpose. So step 4 is you transpose. What is transpose? You change the rows to column. So you change the rows to column. So this 5 minus 2, 3. You write 5 minus 2, 3. 4, 1, 21. 4, 1, 21. Negative 21. 0, 0, 13. 0 minus 0, 13. Minus 0 is same as 0. This matrix is known as the adjoint of A. Okay, we found the transpose here. When we did the transpose of this matrix of the cofactor, that's give me the adjoint of A. Now we go back here. That's what we are trying to figure out. Now we put that value, not here, sorry, here. We put that value in this big formula. When I put in this big formula, I got this one. Now I need to multiply by the 13 inside, 1 over 13 inside. Up to you how you want to do it. You can either do in decimals or you can do without decimals. So what you do is you put a 13 underneath each of these ones. So that will give you the A inverse. You can leave the answer like that, but make sure you simplify as much as you can. Here you can simplify this one, 13 over 13. Yeah, others are a little bit difficult to simplify. So that can be, if you want, you can write that one as 1. Yeah, and that would be your inverse. You can do that in decimals as well. So I will put some questions. Okay, now let's imagine we are given the matrix A and we want to find the inverse. So we follow the same steps. Always step 1. I want you to find out the A determinant. That's the first step. Now, that's the first step. The second step is find the minors, the long method. Then step 3 is diamond, which is changing the sign. Step 4 is transposing the after diamond. And then step 5 is putting in this formula A inverse 1 over A determinant adjoint of A, and that will give you the answer. Just to show you what the answer here, which I copy from online, is that. So if that's your answer, you're right. If not, it's incorrect. Okay, question, all the steps, and the answer is here.